Help, I'm trapped inside a computer. Well, precalc, here I am inside the WAMAP assignment for Skill 3D, find direction angle. I'm going to take a look. Two of the problems, there's only two different types of problems in this assignment. So I'm going to do question 1 as an example and also do question number 7. So over here, we got question number 1, which starts off by giving me a vector u, component form 4, -5. Our job by the end of the problem is to find the magnitude and the direction angle measured in degrees at which the vector points measured counterclockwise from the positive x-axis. Okay, so it doesn't actually say the word direction angle, it says angle, and then it gives you the definition starting from the positive side of the x-axis, rotating counterclockwise. All right, round your answers to 2 decimal places or use radical form. All right, well, here, starting off with the magnitude. Okay, so I remember to find vector magnitude from component form, I need to use a square root, and it's basically a squared plus b squared equals c squared, where 4 is going to be a, -5 is going to be b. So I'm going to do some mental math. 4 squared, that's 16. -5 squared is positive 25. 16 plus 25 is 41. So magnitude is going to be the square root of 41. And yay! And then I'm going to graph the vector for -5. So start from the origin right here at 0, 0. Click and let go. And now that thing is going to follow my cursor around, go positive 4 on the x. So go right 4 and then down 5 to get my -5 in the y component. Click. Okay, submit. Hooray! Okay, so we get a multiple choice question based on what you just graphed. The direction angle of this vector for -5 is going to be someplace on the unit circle. Where? Between 0 and 90, between 90 and 180, between 180 and 270, between 270 and 360. It's a multiple choice. So I need to know where on the unit circle, which quadrant this is in. And I can't actually overlay this on top of that graph, but it's quadrant 4, right? So it's going to be down here, which is between 270 and 360, right? So just you look at the graph, you can say, hey, that's in quadrant 4, and I know if you need to refer back, you can't remember which degrees or where, refer back to this picture in your notes, or right there. It is on the screen. You're seeing it right now, between 270 and 360. Select submit. Yay! I got the little green outline in my multiple choice box. Hooray! And now we're going to give the direction angle. Okay, so to give the direction angle, it does take a couple of steps. So the first thing I'm going to have to do is find my pen. Okay, so I got graph. I'm just going to draw quadrant 4. That's all I need. This vector goes there. I know the components. It's going to go 4 across, -5 down. I don't really need the negative sign, but it goes negative, right? But I already know that. And in order to find that angle, I'm going to use tangent. And so tangent of the angle is going to equal, okay, here's my little graph walker. This is the opposite side. This is the adjacent side. This is the hypotenuse. I don't need the hypotenuse. I have numbers on the adjacent and the opposite. So it's going to be tangent. Tangent is opposite over adjacent. That's the way my fraction goes. So -5 over 4. And then I'm going to grab my calculator. I did not have open yet. Okay, goodbye graph. Graph will come back later. Okay, so -5. 5, I have to hit negative after that. 5 divided by 4 is 1.25. Could have done that a negative one. Oh, I hit negative too many times. All right, that should actually be a negative 1.25 if I'd done it correctly. Keep track of my work. Okay, so to find the angle, I need to do the inverse tangent. Extra page. Give me more. Thank you. More space. Okay. So on my calculator, I'm going to hit I'm going to hit trigonometry first, and now I can hit second in here. My calculator is funny. Inverse tangent. So I got -51.34 degrees. -51.34 degrees. Okay. So what's up with that negative angle measurement? Because my calculator actually can deal with negative components, and it's going to give me the appropriate angle. So this -51.4, is actually measuring from the positive side of the x-axis. That is, in fact, the direction angle. So negative 51.34, if you can read that at all, that is this direction angle started from the positive side of the x-axis. In this case, that negative number, since it is negative, I know it's been measured clockwise, the short direction around. And so to find a positive direction angle, I need to we go. Start from the 360, and since this angle has been measured in the wrong direction, that'll be subtracting. It already says negative on there, so that kind of should be obvious, but sometimes we overthink things. So 360 minus 51.34. That's the direction angle. 360 minus 51.34, and it does say in the directions to use 2 decimal places. If I just add 360, that's the same, right? So 308.66. 308.66. That is accurate to 2 decimal places. All right, calculator goes away, answer goes in here, and it does in the directions. I didn't, this is covered by the calculator, so I didn't point this out. Be sure to give your direction angle in the correct quadrant. Okay, we talked about that already. And the angle here needs to be between 0 and 360 degrees. So even though my calculator told me the negative 51.34 degrees, I can't use that. WAMAP's going to want a positive answer. So I did actually need to subtract from 360. 308.66. Enter. Hooray! All my parts are correct. Nice. I'm so happy. All right, so take a look at number 7 next. So it's basically the same type of problem with just fewer steps. So we'll have to do more on our own instead of the question guiding us through part by part. So I'm still given a vector u. This one's got components -4, -3. Find the magnitude and the angle in degrees in which the vector points measured counterclockwise from the positive x-axis. All right, well, all of that stuff means direction angle, except instead of 2 words for direction angle, it's like a whole sentence that explains it. So, all right, and then this does not have parts. I got my 2 answer blanks. I'm gonna put magnitude here, and I'm gonna put direction angle there. So I can go ahead and do direction angle. Sorry, I'm gonna do magnitude first. We'll do direction angle afterwards. I'll actually show my work this time. I know the last one I didn't. So pen, red, -4 squared plus -3 squared. My 4 got warped a little bit. Equals, I don't have space on the left. Whoops. Magnitude of u. Okay, so 4 squared, that's 16. -3 squared is 9. Positive 16, positive 9. When you square a negative number, it's a positive because -4 times -4 is positive 16. If you type it into your calculator, if you're not careful because you didn't use parentheses, it's probably going to tell you -16 because it thinks that the negative sign is not attached before the exponents. So your calculator, if you just type negative and then 4 and then squared, it's going to square the 4 first, which is 16, and then your calculator applies the negative sign afterwards and gives you a negative answer, which is wrong because you actually want the -4 inside parentheses to be squared. You should get a positive answer. Okay, so 16 plus 9 is 25. Square root of 25 is 5. You might have recognized this as a Pythagorean triple, 3, 4, 5. Okay, there's my magnitude. 5 goes in there. Don't hit submit yet because we still need to get this other answer. I do not need to use a radical form because the answer is exactly 5. I mean, you could type radical 25, but don't because you can do the square root of 25. It equals 5. Just type 5. Okay, direction angle. So this could take a little bit more work. I'm going to I'm going to save that for later. I'll just hang out up there, picture. Okay, so I'm going to draw a graph. It doesn't even have to be a good graph. Here's my x and y axis. And then I'm going to draw a picture of my vector. This just helps me to visualize. So -4, -3. start at the middle. I'm going to go 1, 2, 3, 4 over, 1, 2, 3 down. Just so I know where I'm drawing to, we'll put a dot. So this is -4. This one is -3. I already found the magnitude. Magnitude is always, 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 always positive. It doesn't matter whether your components are positive or negative. Magnitude always will be a positive number. Well, okay, we got +5 anyway, but just rule of thumb. Okay, so I got my little right triangle, and I know the components. -4 is the x, -3 is the y, blah, blah, blah. At this point, you really have a choice if you wanted. You could use any trig ratio. You don't have to use tangent. Since we already found the hypotenuse, you've got adjacent is -4, opposite is -3, and the hypotenuse is 5. You could use sine if you wanted. You could use cosine if you wanted. You could use tangent if you wanted. It's your choice. I'm not going to do all three right now. I mean, that's totally a thing that I could do, but I'm just going to stick with tangent, I guess. So tangent of the mystery angle right there is opposite over adjacent. All right, pull up my calculator. And so I know a negative divided by negative is going to give me a positive answer. I will not type the negatives into my calculator. It takes too long. Way, way too long. It's like what, like a tenth of a second or something. So I'm going to get positive 0.75. I was just being sarcastic about the wood taking too long. I know the answer is positive. I don't need to do extra work and type negatives. Okay, so now I still need to get the angle. So the tangent of the angle is 0.75. So on my calculator, I'm going to, whoops, not there. I'm going to go to my calculator, I have to go into the trig menu and then hit second inside of there, inverse tangent. On your calculator, just you don't have like different second buttons. You just have the one. So just hit second and then tangent. And then you'll have to actually type the 0.75 in there. It'd be nice if we had the same kind of calculators, but I don't have a good way of showing you my TI. You could like hold it up and then you couldn't read anything. So anyway, so the inside the triangle angle is 36.87. If I round to 2 decimal places, it's going to be 0.87. And that is not my final answer, because on my little drawing, I can see this vector is in quadrant 1, 2, 3, quadrant 3. And if I overlay my direction angle picture on here, I know that quadrant 3 is going to be between 180 and 270 degrees. So my final answer should be somewhere in that range between 180 and 270. And in my picture, I can see that the x component lines up on the negative x side of the negative x axis of the graph, which is where 180 degrees is at. So if I go from 180 degrees, if I continue rotating in that counterclockwise direction, I'm adding, right? I'm going bigger numbers. Instead of 180, I need to get bigger, 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 bigger. Not all the way to 270, but more than 180 degrees, right? So I'm going to take that 180 and add the 36.87 to it. So just write that up here where I've got some room. 180 plus 36.87. And let's see, that's going to be a 7, that's going to be an 8, that's going to be a 6. Plus there's 1, carry the 1, it's 2. Hopefully I did my long addition correctly. 3, 3, wow, there's no 3's in there. 216.87. I can double check it on the calculator, but I'm pretty sure I did that right. So let's just type that in here. 216.87 degrees, round my answer to 2 decimal places. I did, I rounded correctly to 2 decimal places. Submit, bam, yeah. All right.